inside the heap sort algorithm, and we just like to know what is a heap. You may have already covered. Heap is a almost complete binary tree. Almost complete binary tree means that we have only one node which has one child, and it must be the left child of that node. So we can only allow one node to have one child, otherwise every node has two children. That is the definition of a complete binary tree. And if we only allow one node to have a child, almost complete binary tree. For example, you are constructing a tree. It is a binary tree and it has two nodes. Again, it has two nodes. Now it has again two nodes. So if you have one node left, then there should be only one parent node that has only one node, and that must be the left node for this binary tree. And this type of trees, binary trees, are known as almost complete binary trees. You can also call them left complete binary trees. This is another term which is used for these type of trees. So this tree must maintain the heap order property, and heap order property has different for different type of heaps. We have two types of heap. One is known as min heap and other is known as max heap. In min heap, we have the smallest value as a root of the tree, smallest value as a root of the tree, and throughout the tree, parent must be small or equal to than its children. This property must hold throughout the tree. Parent must be small for both of its children in the case of min heap. And if we have a max heap, it means that the maximum value should be as a root of the tree, and throughout the tree parent should be equal to or larger than its children if we have constructed a max heap. So, how to implement the heaps? The best implementation of heap is actually one-dimensional array can be used for implementation purpose of the heap. You could recall from your concepts of data structure, to implement any kind of logical data structure, we use two fundamental data structures, and these two fundamental data structures are arrays and linked list. We can use array for implementing any type of logical data structure, and we can also use linked list for this purpose. And when we are using the arrays or linked list, they have different kind of efficiencies. Some situations arrays perform better, and in other situations the linked list performs better for different type of data structures. And if we consider the heap, we can use one-dimensional array for implementation of heap. This is probably is the best implementation of the heap. Heap basic functions, we just explore different type of basic functions which we can apply on a heap. You can see all of these concepts from this almost complete binary tree, which can be termed as a heap. And from this tree, you can observe that the largest value is the root of the tree. So 16 is the largest value throughout the tree, and you can find this largest value as a parent node of this tree. Because this is a max heap, you can find from this heading, this is a max heap. And other property which we should make sure, the parent throughout the tree must be greater or equal to its children, and you can find this property throughout the tree, like 10 is greater and 14 here is greater than two of its children, and 8 is greater than two of its children, and 7 is greater than its only children 1. So this is the basic or fundamental property of the heap. Now, how to implement this heap? For implementation of this heap, you can use one-dimensional array. and if this is a one-dimensional array like this one, and if its indexes are started from 0, you will have to uh, let's say starting index is 0, and this is the index 1, and this is the index 2, and this is the index 3, and 4, and 5, and so on. So what you have to do, you simply save the parent node in the index number 1 of the array. So here in the index number 1 of the array, you will have to save the parent of the tree. If your indexing is starting from 0, you have to leave the index 0 and start saving the tree from index number 1. And after that, you can save the tree level by level. Okay, this is the level 1. You have started saving the tree from index number 1, and then you can save 14 left to right, 14, and then 10, and then 8, and 7, and so on. Okay, if you have a heap, you can simply save this heap in one-dimensional array. And one thing you will have to perform is start your storage process from index number 1, and then you can save this heap level by level inside this one-dimensional array. You can find this storage of the heap from this array. You can observe that we have started saving the heap from index number 1, and after that we have simply saved the tree or heap level by level inside this array. So just so far we have discussed that heap sort is a sorting algorithm which is using the heap, a left complete binary tree which has a heap order property, and we have also discussed that how to implement the heap. The best implementation of the heap is the one-dimensional array where you start saving the tree level by level, but you will have to do one activity very carefully. You start saving the tree from index number 1. If you are using a programming language which has index 0, you will have to leave the index 0 empty and then start saving the tree from index number 1 level by level. So if you